Okay, to find the missing side here, we will use the Pythagorean Theorem. So with the Pythagorean Theorem, we have a squared plus b squared equals c squared, where a are your legs that make the right triangle, right angle, and then c is the hypotenuse. So in this setup, we would have x squared plus 5 squared, because they make the right angle, equals the hypotenuse squared, which is 9 squared. And then we will begin to simplify. So x squared, 5 squared is 5 times 5, which is 25. 9 squared, 9 times 9, which is 81. Subtract 25 from each side. So x squared equals 56. Now we want to undo that exponent square by taking the square root of each side. So the square root, that gives us x equals the square root of 56. Now 56 is not a perfect square, but it can be simplified. And you can simplify this a few different ways. You can find the largest perfect square that goes into 56 and break it down. Or you can use a factor tree or upside down division to do your prime factorization. So if you're familiar with a factor tree, we know that we can multiply 8 times 7 to get 56. 7 is prime, so I'm done with that part of the tree. I can break 8 down to 4 times 2. 2 is prime, so I'm done with that. And then I can break 4 down to 2 times 2. So I could rewrite the square root of 56 as the square root of 2 times 2 times 2 times 7. And to simplify this, we're looking for 2 of a kind. So I see I have a pair of 2's here. That's the same thing as 4. And the square root of 4 is 2, so that tells me that I can bring a 2 to the outside of the radical. Now the 2 times 7 would stay inside the radical because they don't have any pairs. So I would end up with 2 times the square root of 14. Okay, hope you found that to be helpful. Thank you.